Welcome all friend. We are discussing organic chemistry, structure determination of organic compound by spectroscopic method. Herewith we focus on IR stretching frequencies. Before going to the IR stretching frequencies, all of you have familiar about the different factors which affect the IR stretching frequencies are there. Which are these one? The first one, if you look, this is a inductive effect. Second, a resonance effect, conjugation, ring size effect, steric strain effect, hydrogen bonding, and a solvent. These are the different effects which affect the IR stretching frequency absorption. But you must have to know the actual IR stretching frequency for a functional groups. Start with an alkane molecule. The alkane molecule is having the CH is there, which absorbs nearly at 3000 centimeter inverse. Because it consists a sp3 hybridization and which is ranges from 3000 to 2840 centimeter inverse. But if you look for phenylic, aromatic, acetylenic and cyclopropyls, which is having greater than 3000 centimeter inverse because it consists in addition with sp3, sp2 and sp hybridization. The CH2, which is bending vibrations, will be observed at 1465 centimeter inverse is there, and for that of the methyl group, it is observed at 1375 centimeter inverse. When there is a CH2 group, more long chain is there, 4 or more carbon atoms of the CH2, then in 720 centimeter inverse is the frequency will be observed. Now go for the alkene system. In the alkene, there is a terminal alkene is there, which is actually observed at 3000 centimeter inverse greater than in between 3095 to 3010 is there. And if the molecules which is having the out of plane, then it is observed at 1000 to 650 centimeter inverse in between that. And the carbon-carbon double bond, which is a olefinic, which has 1660 to 1600 centimeter inverse in between that. Always remember, everyone know the symmetric molecule does not show air absorption. And then what happen? Some molecules are having the cis and trans geometries there, and in the cis and trans geometry, the dipole moment will be cancelled with each other, so it having the less absorption as compared to the cis will be there. Then in alkyne molecule, if you have to look for the triple bond CH, that is the terminal which observes nearly at 3300 centimeter inverse, while the carbon-carbon triple bond which is observed at 2150 centimeter inverse is there. Then we go for the aromatic compound. In the aromatic compound, the double bond CH, which is present on the sp2 hybridization, this is always greater than 3000 centimeter inverse in between 3050 to 3010, and in the same way, the out of plane will be observed at 900 to 690 centimeter inverse, and that of the carbon-carbon double bond, which is specific in the pair, and observed at 1600 and 1475. Always in the aromatic carbon-carbon double bond, sp2 hybridized, which is having the pair absorption will be there. Then we go for the alcohol, phenol, and ether. The alcohol molecule and phenol molecule, which is having the specific OH group is there. And when there is a presence of an OH group, there may be a possibility of pre-OH or hydrogen bonded OH. If you have the pre-OH group is present, then we have a sharp peak at 3650 to 3600 centimeter inverse. And that of OH group is in a hydrogen bonding, then the peak is not a sharp, peak will become broad in between 3400 to 3000 centimeter inverse is there. If the hydroxy group is attached to the carbon and then there is a carbon oxygen hydrogen air absorption will be observed at which gives broad as well as weak peak at in between 1440 to 1220 centimeter inverse will be there. In the similar way, there is a carbon oxygen linkage is there present between the alcohol and phenol will be there. So it observed at 1260 to 1000 centimeter inverse. This is a similar with that of the ether molecules. In the ether, again we look for the aromatic ether which observe somewhat higher, absorb higher frequency 1250 and 1400, 1040 centimeter inverse, and that of the aliphatic ethers will be observed at 1120 centimeter inverse, somewhat less as compared to the aromatic ethers. Okay, aromatic ether has the two air absorptions, while the aliphatic is having the only one air absorption. Now, the main basic is the carbonyl stretching frequency. And in the carbonyl stretching frequency, there are number of stretchings, carbonyl functional groups, and their stretching frequency you have to look. The first one, if you look for this molecule, this is a aldehyde R C double bond O H, which is having this carbonyl stretching frequency. You have focus over the more. This observed in between 1040 to 1725 centimeter inverse, while that of CH, which is a specific stretching frequency for aldehyde in between 2860 to 2800 centimeter inverse. This is for aldehydic stretching frequency. Sometimes the CH stretching frequency falls down at 2700 also if their R group is aromatic in nature. The second one is a ketone. Ketone molecules is having the specific carbonyl stretching frequency in between 1720 to 1708 centimeter inverse. The third one is a acid functionality C double bond O OH. Now here is there are three IR stretching frequency. The first one is your carbonyl stretching frequency. Second one the OH stretching frequency, and the third one carbon oxygen stretching frequency. The carbonyl is in between 1730 to 17,000 centimeter inverse, and OH is higher in mostly 3400 to 1400, but greater than always most of the time greater than 3000 centimeter inverse. The CO linkage, like a ether linkage, it is present between 1320 to 1210 centimeter inverse. This again ester molecule are C double bond O O R. Here is carbonyl is higher, that is 1750 to 1735 centimeter inverse, and carbon oxygen bond length, this will be going to having the stretch 1300 to 1000 centimeter inverse. Next one is a amide molecules R C double bond O NH2, primary amide or secondary amide will be taken. We have carbon stretching frequency for that in ranging from 1680 to 1630 will be there, and NH group is having the stretching frequency, two stretching frequency for NH2 group and one stretching frequency for NH, that is 3350 and 3180 centimeter inverse, and a bending vibration at 1640 to 1550 centimeter inverse will be centimeter inverse will be found. That of acyl chloride, carbonyl stretching frequency is higher 1810 to 1775 per centimeter, and that of again carbon chlorine stretching frequency, as chlorine is electronegative, CCl 730 to 550 centimeter inverse. This is a stretching frequency will be observed. and another one anhydride R C double bond O C double bond O R. This anhydride is having the two carbonyl as they are having the two IR stretching frequency for both the carbonyl 1830 to 1800 and 1775 to 1740 centimeter inverse. Okay, and CO carbon oxygen is in present between 1300 to 900 centimeter inverse. Now, why this all carbonyl does not having the same IR stretching frequency, they having the different IR stretching frequency. We are going to discuss in the another lecture, that is factor affecting IR stretching frequency, how the electronegative group, inductive effect, resonance effect will be going to affect the IR. Now, look this stretching frequency regions for the all carbonyl group I have put here. Amide is having the smaller in the carbonyl stretching frequency, while anhydride is having the higher in the stretching frequency. Next to the amide, there is a carboxylic acid and ketones, carboxylic then aldehyde, esters. Sometimes the carboxylic acids will be beyond the aldehyde also. Then anhydride, acyl chloride will be there. Now we go for the amine molecules. In the amines, we have the stretching frequency will be observed at 3500 to 3300 centimeter inverse, and they are going to show bending as well as out of plane bending, at 8000 centimeter inverse. If you look the stretching for the different amines, that is primary amine, secondary amine, and tertiary amine. What happened? The stretching frequency due to the presence of two hydrogens, we have the two bands for primary amine. You have the single one hydrogen, NH hydrogen, therefore one band, and there is a no hydrogen is present at tertiary amine, therefore there is a no bind will be present. While in the bending, NH2 groups will be observed at 1640 to 1560, and that of NH secondary amine is specifically found at 1500 centimeter inverse. In addition with that, there is a carbon nitrogen stretching frequency which observed at 1350 to 1000 centimeter inverse. The nitrile molecule, that is C triple bond N, recorded as also cyanide, having the perfect 2250 centimeter inverse IR stretching frequency. Second, isonitrile is having the near about nitrile N double bond C double bond O. This is isonitrile 2270 centimeter inverse, and isothionitrile, except oxygen, there is a sulfur. The IR stretching frequency falls down to 2125 centimeter inverse. And in a nitro compound, the aliphatic nitro compounds show symmetric stretching vibration at 1600 to 1530 and symmetric stretching at 1390 to 1300. While that of the aromatic nitro compounds absorbs somewhat less in asymmetric stretching 1550 to 1490, and that of symmetric stage 1355 to 1315 centimeter inverse. This is about the your aliphatic and aromatic nitro. They are having both the stretching frequency. Generally, we say 1530 1350. Okay, this is the basically found for the nitro compound. Then we look for the carboxylic acid salt and amine salt. In the carboxylic acid salt, there is a asymmetric stretch will be observed at 1600 centimeter inverse, while that of the symmetric stretch will be observed at 1400 centimeter inverse will be there. And amine salt, that is quaternary ammonium salt. This amine salt is having NH stretching at 3300 to 2600 centimeter inverse, and the top NH bending is present at 1610 to 1500 centimeter inverse. In addition with that, mercaptan and sulfoxides, the mercaptan SH bond will be observed at 2550 centimeter inverse, and that of sulfoxide S double bond O, which is near to 1050 centimeter inverse is there. The phosphine pH bond will be observed at 2320 to 2270 centimeter inverse. If you have the pH2 group is there, then it falls down to the 1090 to 1075 centimeter inverse. And the oxide molecule, that is called the phosphine oxide, which is observed at 1210 to 1140 centimeter inverse is there. This is about the phosphine and phosphine oxide. And another one is the alkyl halide. The alkyl halides are going to show in different regions, aliphatic and aromatic. Aliphatic regions, if you look for fluorine, chlorine, bromine, and iodine, they are ranging higher for the fluorine 1400 to 1000, and very less for the iodine 600 to 485 centimeter inverse, and chlorine and bromine in between that will be observed here 785 to 540 and 650 to 510 centimeter inverse. That of if you look for the aromatic regions, it's having the again higher for the CF uh, carbon attached to the fluorine due to the more electronegativity, higher absorption 1250 to 1000 centimeter inverse, and that of aromatic of the chlorine 11,000 to the 1035, and bromine specifically absorb the two bands at 1075 and 1030 centimeter inverse will be there. Okay, these are all the different stretching frequencies will be observed for the functional group. We have just commented over the higher stretching frequencies of that functional groups. In the next lecture, we will look for the factor affecting this higher stretching frequency. And if you are new to my channel, kindly subscribe, press the bell icon, you get the notifications of the next videos. Thank you.